we're to the second half of vectors, and today we're going to be doing something called finding dot products. Okay. Our warm-up is to remember how to find component forms. So again, if they give me points, okay, I'm going to take my second point minus the first point. And we are still struggling with that because you got to watch signs. So using our x's first, it's going to be 2 minus 0, okay, which will be 2. And then my y's, 0 minus negative 4. Now that minus minus becomes plus, so my vector for this one is 2, 4. Number 2 is the same thing. We're going to have our second one minus the first one, 0 minus 2, which is negative 2. And careful here, negative 13 minus negative 1. So negative 13 minus negative 1. Okay, so that ends up being a negative 12 because that minus minus is a plus. For our challenge, hooray for challenges, we've got point P, point Q, but not the vector, okay? So if we have point P, we're going to have the Q minus P. So our x is x minus 6, comma, and our y's, y minus negative 5, okay? And we want that to equal 3, comma, negative 4, okay? So that means I'm really breaking down to x minus 6 equals 3. So x has to be 9. So for my PQ point from Q, oh boy, Q should equal the point 9, comma, and let's find out our y's. Y minus minus 5 is really y plus 5 equals negative 4. So when I subtract 5, y should equal negative 9. So the Q point was 9, negative 9. Okay, if you do not remember, okay, you do need to review briefly scalar multiplication because we are going to use it sometime today. So remember, this is directly from our multiplication notes. If you want to multiply by a scalar, okay, which is a number in front of our vector, okay, you simply take the number times the vector, like super distribution. So this one would become 9, negative 36. Super distribution, watching those signs. If they gave me points, like this one, PQ, I have to find my vector first. So I will have negative 7 minus negative 6, which would be negative 7 really plus 6, which is negative 1. And my y's, 2 minus 0, which is 2. So when I want to find 4PQ, I'll have 4 times negative 1 and times 2, giving me negative 4, 8. So that is scalar multiplication, okay? So if we can do scalar multiplication, can we multiply a vector times a vector? But of course we can, okay? There's an additional video if you want to watch it. I will post it on the Google Classroom as well. That is not me, all right? So what we're going to do is actually multiply a vector times a vector. This process is called a dot product, okay? So this product yields a scalar rather than a vector. So what that means is my answers will be a number, a plain, boring, lonely number, okay? So here is the formula right here. It looks like this. It's U, representing the vector U, dot, that's the name of the process, U dot V. And what you do is you say your U1 times your V1, those are X's, okay? And you're going to add it to your U2 times your V2, that's your Y's, okay? So when we have dot products, we're going to have x's times x's, y's times y's, and we'll add them together. It is very different from everything else we've done, so it's very important to pay attention to what each problem asks you. So we have 3 examples over here. Okay. Example A will look like this. Here's my x's. So I'm going to do 3 times 2, and then I'm going to add my y's. 4 times negative 3. All right. So what is 3 times 2? 3 times 2, okay, we'll make sure you'll know that this is A. 3 times 2 is 6, and I'll be adding negative 12. Okay. So 6 plus negative 12 equals negative 6, and that is the answer to the first problem. That is all you do. Okay, so I'm going to do B down here so I'll have enough room. So B says 2 comma 2 is my first vector. Dot, see the dot? 1 times negative 1. Okay, so we're going to do my x's first. So that's 2 times 1 plus, okay, my y times my y. So that should be 2 times negative 1. 2 times 1 is 2. 2 times negative 1 is negative 2. 2 plus negative 2 is 0. That is the answer for B. Plain, regular, 0. Okay. And last we have C. Let's try C here. Okay. C gives me the vector 0, comma 4, dot 3, negative 2. So what I'm going to do, okay, is just what I've done before. All right. X times x, so 0 times 3 plus, I like to change color, plus y times y, 4 times negative 2. 0 times anything is 0, so I'll have 0 plus, and 4 times negative 2 is negative 8. 0 plus negative 8 is negative 8. That is the answer to the C example. Hopefully you're not feeling this is too bad. I am going to do an additional example and look at some additional properties. If you've not finished writing the notes, pause and write them down. Okay. Additional notes, fun facts. Okay. First fact, if you have u dot v, it's the same thing as v dot u. So that one I care about a little bit. If I take a scalar, okay, right here, scalar c, and I have scalar c on the outside of u dot v, it doesn't matter which one I scale. Okay, I don't like to do that usually. I like to do my inside parentheses first because that's just math rules. This is the 0 vector. Remember that one? That one's the one that's 0, comma 0. If you take the dot product of the 0 vector times any vector, you will get 0. And then this one's pretty useful, okay? If you dot product a vector with itself, you get the magnitude squared, okay? That's just a fun fact. If you go on to pre-cal or take some math in college, that will come back, okay? And it's just faster than taking the magnitude and squaring it. Dot products, I think, are easier than magnitude. All right, we have 2 more examples, and you can notice that these are written differently. At the top, okay, I'll highlight these in a pretty color. So at the top, we have the vector u here. We have vector v and vector w, okay? So you can see they gave us 3 different vectors to use. So we're going to use them throughout the problem, okay? So when I look at problem A, it says u dot v w. So the first thing I'm going to do, okay, I'm going to work on A first. If I have u dot v, that means I'm going to take my u, okay, which is 3, comma 4, and my v, which I hope shows up in yellow, -2, 6. Maybe it won't be so bad because it's a video. And I'm going to dot them. So x is first. Okay, so 3 times -2 plus 4 times 6. Okay, 3 times -2, okay, that's -6 plus 4 times 6 is 24. -6 plus 24 is 18. Is that the end of the problem? No, that's just the part inside parentheses. What it really wants is 18w, which is why we have to remember scalars, because 18w will be 18 times the vector 1, -1, okay, which is a super distribute problem. So we end up with 18, -18 as the final answer for this problem, okay? Now you'll see B has a slightly different problem, okay? Okay, so I'm going to do B in green and blue. Maybe that'll help. All right, so B says U.2W. So I really do want to deal with U in a second. That's 3, 4. But I probably should deal with that 2 first, right? 2W. So I'm going to distribute my 2 first, okay? So I'll have 3, 4 dotted with 2, -2, okay? So I dealt with my scalar. Now I can do my x's times my x's, 3 times 2, plus 4 times -2, that's 6, plus -8. My answer is -2. All right, so that's the answer to B. Okay, if that was too fast, you can go ahead and replay this video. Let me know if you have any questions or need any help. I think that's all for today. You need to try to do your classwork, total of 18 problems. All right, and do check the Google Classroom PDF of notes for more help.